Today I'm going to give, let's say, a small workshop about using some of most famous statistical tests using SPSS software. So for today's agenda, we will first of all identify when to use these tests. So we'll be talking about t-tests. I will be discussing 3 t-tests and when we use each. And then we will talk about the one-way ANOVA test. And then finally, we will be looking at 2 correlation tests, which are Pearson and chi-square. Of course, these tests are very important because in most of the research, even if you'd like to conduct, let's say, an action research, you will be definitely using one of these. These are fundamental, let's say, fundamental tests for any research you would like to conduct. Then after we identify and get the fundamentals, we'll move to see how we can conduct them using SPSS software. Of course, there are many softwares you can use to conduct such tests, and SPSS is one of them. So today we'll be focusing more on SPSS, and if you would like me to conduct another sessions for showing how to conduct them in different software, please let me know later on when we finish this workshop. Or contact me on the email, and I will do my best to let's say fulfill your requests. So I will start with the first test. Is called independent t-tests. So as I mentioned earlier, in this workshop, I will be talking about 3 t-tests. One of them is called independent t-test, and the independent t-test is used for comparing between means of 2 groups. So my null hypothesis, or the hypothesis that I'm going to test, is that the average or the mean of the 2 groups is equal, against the alternative hypothesis that their means are unequal. Of course, I'm not going to get into, let's say, theoretical and mathematical expressions here. I want to make this workshop, let's say, user-friendly and attainable by everyone. I'm not going to talk in details about, let's say, the assumptions and the distribution requirement. I'm not going to talk about that, but just keep in mind, if you would like to compare between 2 groups, these groups are independent of each other. So what is happening in the first group doesn't impact what is happening in the second group. You will be using the independent t-test. Example on that, if you would like to test the average GPA of male students, is significantly different from the average GPA of female students. We as academics usually conduct or ask ourselves that if I am teaching two groups, two classes, and I want to test whether their average performance in significant in a test that are significant difference. So in that case, I'm going to use the independent t-test. Another example is to test whether exercise or weight loss is best for lowering the average cholesterol concentration. So I have exercise and weight loss, and I want to check if which one is better in lowering the average cholesterol concentration. So these situations and other situations where you have 2 groups, I would like to emphasize on 2 groups, and these groups are independent of each other, and you would like to compare their means or their average scores. So you will be doing the independent t-test, and we'll show you inshallah later on how to do that on SPSS. The second t-test is the paired t-test. And for this test, as to compare the means of two measurements taken for the same individual object or related units. So for example, let's say that you have a group of students, and before you did teach them a specific lesson, you give them a test. Then after you give them that lesson, you give them the same test. And then you would like to compare their results, um, and see if they benefit from the class that have been delivered. So you are doing the test on the same group before treatment, we call it in statistics, and after treatment. So your hypothesis, the hypothesis that you would like to test is that their performance or their average before taking the treatment is similar to their average after taking that treatment. So in this case means if the average was similar, statistically insignificant, means that they didn't benefit from the class that you have delivered, because there was no, let's say, improvement in their performance after the class. Against the alternative hypothesis, which says that their performance is different. So their average, let's say, score before the lesson is unequal to their performance after the lesson. So the difference between this test and the independent t-test is that here you are looking at one group before and after giving them a specific treatment, or let's say for us, especially for academics, let's say for example a lesson, and you would like to test their let's say improvement in a skill or knowledge. So examples to test whether certain training program can increase the average max vertical jump of college basketball players. Okay, so before that program, their vertical jump will be tested or measured, and then after they gave them the training program, they will check their max vertical jump again, and uh, from that we will apply pair t-test to check whether there's difference between the average max jump before and after the training for the same group. Another example is to test whether exercise or weight loss is best for lowering the average cholesterol concentration for a specific group. So for previous one, it was for two groups. Here for one group, you give them the exercise and you see before and after that exercise. Uh, Also, we have one-way ANOVA. This test is similar to t-test, but the difference here is that you are comparing between more than two means. You are comparing between three and more averages. So, for example, let's say an academic have four classes, and he or she would like to compare between their performance, average performance in a specific test. So you can now imagine between or compare between independent t-test here. It has to be two groups. But if it is three or more, you cannot use t-test. You will be using something called one-way ANOVA. Okay, so ANOVA is similar to t-test, the independent t-test, but this is for two or more. And for two groups, let's say, ANOVA output will be similar to t-test, will be exactly the same. But if you have more than two groups, then you cannot use t-test, independent t-test. You will be using ANOVA t-test. And your null hypothesis will be that the average of the first group is similar to the second group, similar to the third group, and up to the number of groups that you have. So if we apply this on, let's say, students' performance in three classes. So the average performance in the first class is similar to the second, is similar to the third. So there is no difference between the average performance for the three classes you have against the alternative hypothesis that there is difference between them. And this is an example testing the effect of different diets. So you can see here 1, 2, 3, and 4. So you have 4 groups on average weight loss. So you want to see which of these diets are better in losing weight. Okay, so you can see you have 3 groups here: low fat, low calorie, low carbohydrate, and low protein. So let's say that assuming that we have only low fat and low calorie. In that case, I'm going to use independent t-test. But here, since I have 4 groups, then I have to use one-way ANOVA. Then moving to the, let's say, correlation tests, I'm going to discuss 2 tests here. The first test is called chi-square test. And the purpose of using chi-square test is to see if there is a relationship between 2 categorical. I want to put 2 lines under categorical because this is the key difference between this test and the test coming later. So you have nominal or ordinal data. You want to see whether they are independent or related, or what means dependent. So your null hypothesis that there is no association, so that means they are independent of each other, against testing the alternative that there is relationship between these two categories or categorical variables. For example, if you would like to test if there is association or relationship between gender and voting preference. So here you can see, I don't know if you've been or you have experience in doing analysis for categorical data. What do I mean by categorical data? This type of data, actually you get them as categories. They are not numerical. Okay, so and if they are, and you are converting them into numerical data. Like for example, of course you've come across questionnaires. Any questionnaires, some of questions are related to male and female. So when you analyze the response for that question, the software will not understand male and female, so you need to code them. You replace them with code. So for example, for male you put 0 and female you put 1. Okay, so for such data this is called nominal. Okay, this is different from the data that's related to, let's say, for example, measurements. So for example, let's say the temperature, for example, today, or the temperature per each hour in a day. This type of data is a numerical data, and it's continuous, we call it in statistics. So for such type of data, you can analyze it easily. But for categorical data, you need to tweak it a little bit in order to make it easier for you uh, um, to analyze. The other type of data is called ordinal. Ordinal means that there is difference between these data. Like for example, the questions that ask you for to rank whether you like, dislike, I don't know, like it very much, don't like it very much. So in that these questions, there is like difference between the selections. So this type of data, you call it ordinal. So if you put 1, that means, let's say, less preference, let's say, option. And let's say if you rank it from 1 to 5, 5 will be the most preferred, for example, response. So these are the difference between nominal and ordinal. For this type of data, you need to use something called chi-square test. Finally, for Pearson correlation, this is for testing again, the relationship between 2 variables, but these variables are continuous. For example, as I mentioned, the temperature, for example, for let's say number of days. or the height of, let's say, students in a class. So when you measure them using numbers, and these numbers are continuous. What's the meaning of continuous? يعني you can have uh, results with decimal points. Okay, يعني like 3.5, 3.6, 3.7. You have points here, decimal point. So this type of data is called continuous. And if you would like to measure the correlation between this type of data, you cannot use chi-square. You have to use Pearson correlation test. And this test will test the linear relationship between these variables. If you get a result that's very close to 1, that means that the correlation between these variables is strong and positive. What's the meaning of positive? Means if one of the variables increase, the other will increase. If one variable decrease, the other will decrease. So the other will respond in the same direction. If you have a result of, let's say, close to -1, means you have a strong relationship, but it is, let's say, negative. Okay, what's the meaning of negative? Correlation means you have opposite direction. So if one of them is increasing, the other will be decreasing, and vice versa. If the answer very close to 0, then that means there is no relationship. And example on that is testing if a linear relationship between a student's studied hour and their exam score. So for example, let's say you want to test whether in your class, whether there's a correlation between how many hours the students spend on studying for a specific exam, and whether that impact their, sorry, not impact, there is a relationship between it and the exam score. So if you would like to do this, you can apply Pearson correlation. And now we will be seeing how we can do that.